How's it going, everyone? Cup of Science Joe here. I got a new camera. So here it is in front of me. I hope things start looking better than before, and I am certainly excited to be moving away from using a webcam. Although I will say the webcam certainly served its purpose. And so for today, I wanted to try doing something a little bit different and that maybe was a little bit easier as well, so I could couple it better with learning how to use this new camera. And so I'm going to talk just a little bit about why I think we are living in an exciting time to be a part of and into astronomy. And this is going to come along a little bit of history and, kind of where we started and where we've come to today. So, kind of like I mentioned earlier, I truly believe, no pun intended here, that we live in a stellar time to be a part of or into astronomy. Whether you're a professional or you're just an amateur wannabe like myself, it's just like a great time to be a part of it. This really stems, I think, from just how much we can observe with our current technology. But let's jump to the past for a bit, just to see kind of where we came from. Astronomy has been around for a long time, probably since antiquity, right? Since there are some things in the sky that are just, there's actually a lot of things in the sky, that are just visible to the naked eye. So, a lot of the constellations and stuff, the Greeks and people from those time periods were naming those things for us. But I want to skip to the point when we really started being able to use instruments as well to help view things in the sky, instead of only using our eyes, right? So telescopes first started coming around in the early 17th century. To talk a bit about this, we're going to turn our attention to Galileo Galilei. While he did not invent the telescope, he did introduce, design, and build telescopes with increasingly higher magnifying power. His first telescope, which was an early refractor, was basically a tube with two lenses inside. He first started out with a 3-power instrument, then followed up with one that could magnify objects by up to 9 times, so probably more like a 9-power instrument. Observations made with his telescope strengthened the idea that the Earth and other known planets were orbiting the Sun, rather than everything orbiting us here on Earth. It also revealed many stars in the Milky Way that simply were not visible with the naked eye. One of my personal favorite things Galileo discovered with his telescope is the 4 largest moons of Jupiter. These moons are Io, Europa, Callisto, and Ganymede. I want to note that because Jupiter is an object you can see with your eye, I don't really think we know who discovered that, but it's these 4 largest moons that became visible to Galileo in his telescope. This technology really helped kickstart our ability to study the planets, the stars, and space in general around us. But even with telescopes, we still had a limitation: our eyes themselves. As an example for this, let's turn our attention to Percival Lowell. In 1896, he commissioned the 24-inch Clark refractor telescope. But I actually got to see this, it was quite cool. It was built by Alan G. Clark and ended up in Flagstaff at the Lowell Observatory. This was one of the observatory's first instruments and was Lowell's primary telescope for observing Venus and Mars. Lowell had become quite convinced that he had spotted an immense network of canals carved into the Martian surface. This led him to become quite convinced that an alien race occupied the planet. But when photographs were taken of the surface, no such canals were found. And of course, we know today now that this is not true, But it highlights the importance of the next advancement that I kind of just teased a little bit before this, which is the ability to use cameras with telescopes to allow a machine to do the viewing for us, right? It kind of takes out the bias that the eye or a human might see. For another good example, at Lowell Observatory, Pluto was discovered in an early form of this technology called a blink comparator. And it just goes to show that, there are some things, even with telescopes, we can't see, but that a camera can perceive for us. Nowadays, we can use cameras to take beautiful and majestic photos that, again, we would never be able to see with our eye. And this has allowed us to learn so much more about the objects we are viewing. But the Earth has stuff that likes to get in the way. And so ground-based telescopes, even with imaging technology, themselves have limits, as the Earth's atmosphere blocks some of the wavelengths of light coming towards us. And even just a simple cloudy day can put a hamper on observations. But with the advent of space telescopes, we can get around even that. The two I would like to mention here today, very popular space telescopes, the Hubble and the James Webb Space Telescope, are our powerhouses for observing in the visual part of the spectrum, which is Hubble, and the infrared part of the spectrum, which is JWST. JWST is also particularly amazing in that it is around 1 million miles away from us here on Earth, which is nearly 4 times further than we ourselves have traveled. The moon's about 238,000 miles away from Earth or so, and that's the furthest we've gone as humans. To me, this is truly amazing. Now, I mentioned earlier different wavelengths of light, and I've actually talked about a few here on my channel, infrared and gamma, just to name a couple. And, there are many sources in space that radiate their light in various wavelengths of the electromagnetic spectrum, far more than just the visible light portion that we can see. In fact, even me, at the incredibly amateur level, can use this small dish in my backyard to pick up radio waves, one of the parts of the spectrum. With ever-improving detecting technology, we now have the option of viewing stars, planets, nebula, and all manner of objects in the sky in whatever part or parts of the electromagnetic spectrum they radiate. And this, it can teach us so much more about an object than we could simply have learned by looking at it. Something that was huge for Galileo in his time a mere 400 or so years ago. Stepping even beyond this, and what I think is into the future, we have facilities like LIGO, the Laser Interferometer Gravitational Wave Observatory. With this, we can even use cosmic gravitational waves to study our universe, and allowing us to detect distant, large-scale events such as black holes emerging, something that I don't think we otherwise would have been able to really study or know about. And I would also like to highlight our current ability to not only look at planets and distant objects, but at least for the solar system, visit them as well. Our most recent robotic explorer to land on Mars, the Perseverance rover, also had a first-time flying companion in the Ingenuity helicopter. While Ingenuity sadly has drawn its final breath, it has shown us that we are capable of powered flight in the thin Martian atmosphere, which I think is an ability that will surely open up our options for exploration going forward. When I watch this footage of Perseverance landing, it truly fills me with awe. Not only because we are able to do this sort of thing now, but also because it can be recorded in such high definition. Imagine being able to look up not just at Earth's sky, but at the sky of other planets as well. We have also visited the outer solar system with numerous missions, but really only within the last 50 or so years, within the lifespan of many people still alive today. To me, all of these things demonstrate not only how far we have come in such a short amount of time, but also they instill me with a sense of excitement to be alive at this cusp of advancement and exploring our universe. And I hope you get excited about it too. I hope you've enjoyed this and maybe even learned something, and I implore you to step outside tonight and look towards the stars.